Hey everybody, I hope there's someone out there and that you can hear me okay and see the stream okay. This is a bit of experiment for me because I haven't done this before. So if you're in the chat, can you just let me know if you can hear me okay and let me know if you're currently looking at a big picture of the sun. I think Joseph Hitchy was in the chat. Could you let me know, Joseph, if you can hear us okay? Well, I'm not sure just yet if anyone can hear the audio okay. So I just hope that it's working, and we'll continue. I'll just give it another minute before we get right into it. Yeah, Joseph says that he can hear us. That's good. Thank you, Joseph. Could you also please let me know if you can hear Goran Mitic?
Yeah, thank you. Jordan, can you hear me? Are you able to hear?
Okay.
Of course, I don't hear you, but maybe later I can hear
you. Audio is good. Okay, we've got confirmation. So, welcome to our discussion. Our discussion between me, Dylan O'Donnell, and Goran Mitic. I will let Goran introduce himself. Goran, who are you, and what are your qualifications?
Hello, everybody. As you said, my name is Goran Mitic. I am from Serbia, physicist by education. I'm 54 and do my own research in physics and all kind of different things since I think 1984. But basically, this story about the new paradigm of the universe started accidentally for me, unexpectedly, in 1997 by having not just Eureka, it was like a real revelation about anti-gravity during my watching into the huge fire, like 10 meters high. So I got clear understanding and realization that it is anti-gravity phenomenon. So starting from that,
Goran, before we go too much further into the theory, can you tell me what sort of a physicist are you trained to be?
I did study general physics.
General physics, yeah.
It wasn't, any specific general physics, yeah. All included, and like preparation to be like a professor.
Mm-hmm.
But I never entered really to be professor. I was only doing some other things.
Okay, so I think now for people who aren't familiar with what your claims are, you do have a few challenge videos on YouTube, challenging certain organizations and the status quo for science about what you believe. So tell us, in about 2 minutes, give us a brief summary of what you believe.
In late 2013, when I was in Toronto, I launched debate by the name Hollow Boiling Lava Stars versus Dark Matter. End of 2013 was the last experiment which was meant to discover dark matter, and it failed like third in a row, even 800 more sensitive than the previous one. So we tried to discover dark matter looking underground, in orbit everywhere, but we can't find it. So that was like a triggering moment for me to launch this debate. And this is the new paradigm of the universe, basically. And we all search for the fabric of the universe. What is the fabric of the universe? And my discoveries are leading to the very simple solution, which we see everywhere around us, that it is rock. On this planet, it's called rock on the surface, but it's liquid rock, deep down. And also, it's the same story in the universe. So if fabric of the universe is everywhere, must be also here. So what's the predominant material here? It's so simple, it's obvious. It's rock. So we have a pattern of the universe which doesn't see 96% of the universe. So you do very good, photos, and we have, kind of, you know, big observing instruments like Hubble and some others. And it's very, very unlogical that we can see only 4% of the universe now, such a big and developed technology. So something is really missing, and we're really missing this book. So my discovery is very simple, it's obvious and logical. So we will go through that, But as I said, it started excellently from 1997 with the revelation of anti-gravity, then realization that fire is anti-gravity, then realization that mass is relative according to temperature. We know about Einstein's relativity according to speed, but speed and temperature are always inseparably connected. So my contribution to the physics is temperature relativity on a mass, which I wrote a paper about in 2000 and did some presentation in St. Petersburg as well. And after that, I started to research, sun closely, because I have discovered that relative mass is relative according to temperature in such a way that mass can be decreased and increased in the, quantity, but also can change the quality and become repulsive. So it's really, fundamental, contribution to physics that mass can be even repulsive. So with the increase in temperature, we have decrease of the mass and quantity. Then we have going to the 0 point or massless state, and then we go to the repulsive mass. When I have realized that, then I realized that hot fusion is not possible. From that, I started to research what stars are, and doing the closest research possible, on the data and everything we know about the sun, I have realization that sun is basically liquid boiling lava. It's boiling lava, not just hot, but boiling.
So
because liquid can be hot, cold, but can be boiling with lava.
Yeah, your claim though is saying you're essentially saying that the sun is not plasma, which is what we believe it to be, the separate state of plasma, but still liquid and just very hot rock.
Plasma is basically, you have solid, you have liquid, you have gas, then you have plasma. But it is gaseous state. Just, you have atoms without, some of the 8 electrons, or maybe all of them, but it is gas. And basically that's the wrong assumption, and that's the reason why we are missing so much of our universe.
But hang on a second. This is a pretty wild claim. You understand? Like when you say this, that the sun is made of lava.
I understand that.
There are huge issues with what you're saying. So before we go any further, as a general physicist, you're coming at this from a theoretical perspective, where you've come up with mathematical models that you believe are borne out by your theory of the sun being lava. Is that correct?
There is no mathematical model.
Right.
I'm on the base, first to discuss about the logic. If we can agree about the logic, then we can go further, making some mathematical models very carefully, because now we have such a big number of models, which are mathematically correct, and we can discuss which one is really good or not.
Yeah, but generally speaking, though, the way astronomy and astronomical science goes is that a theoretical physicist will come up with a prediction, like you have, that certain things are a certain way, and then they come up with a mathematical proof, and then they hand over to the observational astronomers to then go and prove that proof. So, but you haven't even got to the mathematical stage yet. This is all just conjecture.
No math. It's too much math in physics. That's the problem. We have too much math. Don't do it. No, it is the mess. When they ask me, my nickname is Mita. So, Mita, do you believe in a string theory or some other theory? Say, okay, which one? Because we have, done by many scientists, many different theories on the same subject. They're all mathematically correct.
If
So which
you
one we will pick? Are we going to casino and pick one, by chance, or how?
if you had if money was no object, what kind of observational experiment would you use to prove your theory? Um, what kind of test we could do with telescopes or with probes that would prove to you that the sun was lava?
We don't have to do anything. We already have everything what is needed. We just have to realize what we're looking at. Your photos are great. They exactly show what they're talking about.
Well,
it's so sharp. When you look at the sun, it's so sharp.
Now, you mentioned this in one of your videos. You said that this looks like fire to you. And, I sort of get that. Like, it sort of looks like fire, but in other ways, it's nothing like fire.
Okay. So we are looking at basically, we are looking on this photo, we're looking at the body of the sun. It's the surface of the sun. It's the photosphere. So the atmosphere, we don't see, here really atmosphere of the sun, which is obviously gas. But you can see that this is not the same phase of the matter. It's so, much more dense, and it's so sharp and distinctive that you can see such a thing, precisely, what is what. It's like really clear drawing. If you have real gas there, it's not possible to be so sharp and to see such a details as we can see.
But
so that's one of the main things that it is visible.
Look, one immediate problem I have with the theory is that when we observe the solar prominences, when we observe the sunspots, when we put our magnetron on the sun and look at the magnetic field of the sun, it's all full of poles. These, you can see these loops have a north and a south pole. Now, magnetism like that is only created with the temperatures that you get with plasma.
Okay, I know the mainstream theory about it. You're very good. You know that very well. But as you can see, on this photo, you see the eruptions of magma, which goes up and down. So there is some loops, which do look like something magnetic, but it is not magnetic. It's just the sprays of liquid lava which goes up to a certain height and falls down back because
no, it's magnetic, Goran, I assure you. And this is the result of what happens when you point a magnetron at the sun. You can actually see the loops and you can see the fields. Now, if we compare this to Earth, which is made of magma and lava, it's a completely different picture. We only have basically the one field with one north and one south, because the Earth isn't made of plasma. When you get up to those temperatures where you have plasma, there are north and south poles all over the place, causing these loops.
Okay, so what is the solar wind? Can we agree that solar wind is the stream of the electrically charged particles?
Yes.
Okay, so whenever some electricity moves, creates magnetic fields. Okay. Whenever we have some ejections, and we have over the sunspots. Sunspots are basically volcanoes of the sun. Why the sunspot is darker, what we see, than the other surface of the sun?
Because it's cooler.
It's lava which came out on the surface. But of course, you have the stream of the gases going up, which will speed up, with such a speed that they do ionization and they basically create magnetic fields. So no problem with this. No problem with this. Yes, magnetic field looks like this. I agree with that. But it doesn't disagree with what I'm talking about.
Oh, I think it does, because the source, it's the source of the magnetic loops that are the sunspots. So it's not like a volcano that just opens a hole and spews out something. It has a pair. It has a partner that then has a north-south polarity, and that's where the loop comes from. And that is a property of plasma. Now, I'm going to move on to the next thing
plasma is in atmosphere of the sun. I agree. Plasma is in the atmosphere of the sun, and that creates this loopholes of magnetic field.
So you
but
think
you
think the lava is underneath the plasma?
Yes. Yes. No, when something is boiling, like liquid lava boiling, boiling means creating, the bubbles of gas. So that gas is so hot and, repelled by sun because it has, such a matter in a gas state, so hot, has repulsive mass. And it's, repelled by sun, speeded up, to the such a speed and such a temperature that becomes plasma and creates a magnetic field.
No, that makes no sense because
let me remind you about one thing. You have what's the temperature of the sun? We estimate like 6,000 degrees or less. But then when we go away from the sun, in the chromosphere we have 20 to 30,000 degrees. And when we go further away, to corona, we have a million or few millions of degrees. So how is that possible that we are getting more and more and higher temperature getting away from the sun? It's a puzzle which is not solved yet. But my discoveries are solving that, logically and simply.
Okay, so I'm going to move on to the next point, which is the spectra. Okay. So you probably know where I'm going here, right? When we look at the sun's spectra, we get a really quite straightforward breakdown of all the elements. Obviously, the most of it is hydrogen, and then helium, and all the rest of them are trace elements: oxygen, carbon, nitrogen, silicon, magnesium, neon, iron, sulfur. Now, when you look at
that's very important. That's very important. How they come to existence. The older one, the heavier one. When sun can't create anything heavier than helium. That's my question.
The heavier ones are created by supernova.
Which one?
It's the recycling of matter, and when supernovas explode, that's when the temperatures are high enough to create those elements.
Okay, that's the mainstream explanation. But every star has a solar wind, which blows away matter from the star. Do we agree with that?
Sometimes when the plasma escapes its magnetic loop and breaks away, that's when we get flares and solar winds.
Okay. Solar wind. Do you understand what I'm talking about? Every star, even the sun, creates solar wind, which blows away the matter from the, mother star.
And yet volcanoes don't do this.
NASA and the blow of the solar wind pushing matter away from the star.
Mm-hmm.
So every star creates its own solar wind, which blows everything away. The matter. It's the speed of the solar wind on the distance of the Earth is like more than 4,000 k's per second. So that's the speed of the solar wind, at the Earth distance.
Yeah, it takes 8 minutes to get here.
It blows everything away. So how is it possible that heavier elements, which can come, in the form of some gas or some, like individual particles, they can't even approach closer to any star because star by solar wind blows everything away. So that's the reason why it's not possible to come from the supernovas. Even they don't create, but I will not go there now.
Well, the sun has a massive density and a massive gravity. They can definitely, when stars run into each other, when binary systems collide, when galaxies collide, stars can coalesce into much bigger things, or black holes even if they get big enough. They definitely have a dense gravitational attraction to things. They're not just big repulsive objects.
Okay, but do you understand by saying this, we're getting to the mainstream paradigm which says, oh, we need Big Bang, we need colliding with the stars, we need this and that. We always need some miracle events, to get something what we see. My explanation is so simple and logical that doesn't require any miracles. And according to Occam razors, I'm the best one to explain what we are seeing.
Okay, so Occam's razor tells me, I'm looking at a light spectra that tells me it's 91% hydrogen. If this was made of rock, if this was coming from rock, we would be seeing oxygen, silicon, aluminium and iron as the main constituents of those things. That's the composition of lava. Occam's razor tells me that we are looking at a big ball of plasma.
Okay, let me explain that. Let me answer the question. So, from the boiling rock, from the boiling lava, comes bubble of the gas state of magma. So, as we have water vapor, we have also vapor of the stone, which is so hot with a repulsive, mass, which is at that point repelled by sun. That means that it is speeded up, and due to that speed, it increases the temperature. That's the reason why we are having, increase of the temperature by going away from the sun. So the gravity of the sun, the mass of the sun, which attracts everything which has attractive mass, now repels the gases which have repulsive mass. Increase them in speed, increase them in temperature, and disintegrate thermally to the hydrogen and helium, which we see basically to the protons and the alpha particles, right? Which we can see, and we see them like a hydrogen and helium. That's absolutely okay, and I agree with that. But that's the just point. My point is that stars are creating hydrogen, working the way as I have discovered, like anti-gravity, furnace, and creating hydrogen and helium, not vice versa.
Well, that sounds like a really convoluted way of explaining the spectra. That doesn't sound like the simplest way to me.
Okay, say it again. We were talking at the same time, sorry.
I was just saying that explanation isn't a simple one. It's extremely convoluted, relying on multiple layers that convert into these elements that we're seeing in the spectra. I don't think that's how a lava-based star would work. But
okay, we are blind. We are blind by hydrogen and helium. That's the reason why we don't see background, which is basically the origin of the so the heavy elements and heavy items starting from the surface and going towards us are going to through this thermal disintegration from heavy element to the particles of alpha particles and hydrogen. And we see, hydrogen and helium, but we are blind with the basically, the outcome of the thermal disintegration of heavier elements. So we see the front, but we are blind to see what's going in the beginning.
Well, actually, we're not blind, because if you look at the neutrinos coming from the sun, you can actually peel back the sun's external layers and look right into the core. Now, you have another theory, before we go into neutrinos, you have another theory about the core of the sun as well. Can you explain that briefly?
We have just a theory. What we are talking about now is just a theory.
Well, so is the lava one.
Just a theory, it's just a theory. Why we do believe in any theory? The history of science is basically constant change of one theory with another theory, which is better and better and better. So why we do assume that nowadays we are so smart that we have a final theory of anything?
No, we're not assuming. You're coming to us with a theory with no mathematical proof and no observational experiments at all. The status quo has both of these things, mathematical proofs and tons and tons of evidence, observational evidence. Now, I'm asking about your theory about the core. You mentioned that in one of your videos that you believe the core is essentially hollow or full of anti-gravity. Is that right?
Exactly. All stars are hollow, and as well planets are hollow. So that's the pattern in the universe. Only the small objects, which didn't have enough time, to rotate, which cool down so quickly, they can't have hollow inside. Whenever liquid rotates, it creates hollow.
So anti-gravity is a pretty rubbery topic in science anyway. Do you actually mean antimatter?
No, no antimatter. It's anti-gravity. So, my book I was writing about the temperature relativity in general. So everything changed with the temperature. Why the mass is now in the present, mainstream physics? Why mass is now out of that relativity? How can that be? I must, mention that Russian scientists did experiments with metal rods, keeping them up, and they did measure decrease the mass. So what I'm talking about has some experimental proof that mass is relative according to temperature. So
now,
that's the missing thing in the present. You and the mainstream physics is mainstream physics. I know that, but this is something new, and I know that it is not easy to accept and to understand. But I was working, for years on this.
Yeah, it's not a matter of me just trying to.
I understand that it is hard for you to.
No. It's not a matter of me just blindly accepting or trying to open my mind to it. You don't have any proofs for this, and you don't have any observational or theoretical evidence just yet. So I'm just trying to pick apart the very periphery of your arguments here. Now, you are still saying that the sun is hollow. Anti-gravity is a concept which hasn't even been ratified by science yet, so it can't even be properly defined for the interior. But if there's nothing going on in the core, or it's essentially hollow, then are you saying that there's no nuclear fusion happening on the sun?
Hot nuclear fusion is not possible. Only cold fusion is possible, which is now again back in experiments, and it was suppressed for a long time, but now it's back in the experiments. So hot fusion basically is impossible because we estimated that in the core of the sun we have 14 million degrees, because that's the temperature which allows such a speed, thermal speeds, which can overcome Coulomb forces of repulsion. But when you add to that with the increase of temperature you have basically decrease in mass, and basically you are going to have the repulsive mass, the probability for hot fusion to happen, it's even less with the hot temperature.
Well, look, Goran, when I don't fully understand where you're getting at, how you're getting at this our energy-giving sun being just lava and all that energy coming from just lava. But when nuclear fusion happens, neutrinos are released, and this is a photo of the core of the sun. So we can detect and we can image neutrinos from the sun, and we can point a detector at the sun and look inside at the core. So you're looking at the photo of the core now. You're telling me it's hollow, and I'm showing you a photo of the core.
Okay, great. I didn't have to see this photo, but this photo basically, for me, it really represents that. It just represents, inside the star is a furnace.
It's nuclear fusion, Goran.
Okay, I know. What you are in a mainstream. I'm in a new part of the universe.
No, just a second ago you told me nuclear fusion was impossible, and that the sun was hollow. Now I'm showing you a photo of the inside of the sun generated by neutrinos that come from nuclear fusion. This is very simple.
Okay, what if they are not created and generated by nuclear fusion?
No, they are, because the neutrinos have a particular makeup. It's called neutrino oscillation. After an 8-minute journey through space, the neutrinos change type, and based on the rate of change and the exact types that they get back, it fully matches their model for nuclear fusion. We can do this on Earth and receive neutrinos. We know what this is. We know what we're looking at. This is evidence that what you're saying is completely wrong.
It's not. It's not. Believe me, it's not. Even it looks like. Okay. So we tried to make hot fusion here for how many decades now? Is it 6 or more?
Yeah, it takes a lot of energy, but we can make plasma occur in laboratory conditions for brief amounts of time, and we can observe neutrinos off of that nuclear fusion.
Okay. There was no luck, money, people, smart people, brains, to do the job. But even today, we didn't come to the result we wanted to have. We do have a bomb, which we believe that it is fusion bomb.
Wait! Get back to the core, Goran. I've just shown you a picture of the fucking core of the sun. You have to tell me how this impacts your worldview that the sun was hollow.
The sun is hollow, and the furnace even have inside the temperature is even bigger than on the surface and in corona. That's the reason why is that have to release pressure from the core to north and south pole, and that's the reason why every star glows matter and gases from the north and south pole, which we can see, and we see that like a pulsars.
This is nuclear fusion. This image is made from neutrinos that come from nuclear fusion.
We assume that it is nuclear fusion, but there is I told you that it is the furnace. If you have something, like an orange, and you have just, like a core, and everything inside is empty. When it is boiling lava, it's boiling inside and outside. So the gases which are boiling inside, creating more and more pressure of hot gases, inside. So this can be exactly the photo of the process I'm talking about.
No, if this was gas, if this was heat, we wouldn't be able to see it. This photo was taken from the opposite side of the Earth. The neutrinos actually came from the sun and 8 minutes later went through the Earth and then were imaged by a team in Japan using a neutrino detector 3,000 feet underground. This is unmistakably the signature pattern of neutrinos coming from nuclear fusion from the middle of the sun. Now, if you tell me it's not, this is like me showing you a photo of the round Earth and saying, no, it's flat. I'm showing you the sun's core.
This photo shows that neutrinos has come from the core of the sun.
Yep.
It's just that. We believe it's not fusion.
No, we know, because we can do fusion and we can get the pattern of neutrinos and we can get the matching pattern of neutrino oscillation that shows the changes over 8 minutes through a journey through space.
Okay, let's go to the surface of the sun. Can you show some photo? Okay. So how you can see this on the top, which is clearly eruption of the lava. If it is gas, it will disappear like fire, like anything else.
This is not clearly an eruption. What I see clearly are loops here. These are magnetic loops. Lava doesn't come out and come back to the Earth in a perfectly north-south magnetic loop. That only happens with plasma.
Okay, so I have to send you links for the videos, which are,
I'm going to go back to this. I reckon this photo was making you the most uncomfortable, Goran. The photo of the core.
This photo just shows that
it's beautiful, isn't it?
Are coming from the core of the sun.
It's nuclear fusion in the core, which completely contradicts what you're saying about the core being hollow and no nuclear fusion happening on the sun.
furnace inside the sun, which creates even hotter temperature than the surface of the sun. So it can come from that reactor inside the sun, which I'm talking about. So the source can be the reaction can be different than the hot fusion. This is just showing that something going on in the center of the sun.
Yes, it's not hollow, Goran. Now, before we go on, I just want to understand. You are on YouTube. You were sharing things. You were doing lectures. Why haven't you sat down and written the mathematical proofs and published a paper on this? Why don't you go down the normal route of scientific inquiry and publish?
I did the paper, temperature relativity of a mass, but what I'm talking about, it's so it's so obvious. So what I'm talking about is the thing which we can see now. We can observe the sunspots. Do you know how really sunspot looks like with the shape? It has the depth. It has like a cone shape. So how that can be possible, in the gas?
When you're looking at sunspots, you're looking at a temperature difference. What you perceive as depth.
Sunspots are really closely, I don't hear you now. Dylan, I don't hear you now.
I was just saying that sunspots are a photon representation. When the photons hit the chip on the camera, it's because we're looking at a colder region, and when we have the hydrogen alpha filter or the white light filter, we're just seeing patches where the light hasn't been generated.
Okay. Let me explain. Let me explain what the sunspots are. They have 3D. They have shape in 3D. They're like a cone. It's not. They have 3D shape, and that can't happen in something like a gas. Simply can't.
Yeah, and
then they flow.
And they have polarity, and that can't happen in lava.
Dylan, I have a breaking in hearing you.
We're repeating ourselves now, so I'm going to start to wrap this up. But there are a few questions in the chat, so I'm just going to check these. And YouTube YouTube is brutal, and the feedback that you're going to get is going to be harsh, because what you're saying sounds completely mad. It sounds mad to me, and it sounds mad to a lot of people. So let me see. I'll just scroll down here. How thick is the layer of lava surrounding the hollow core? Pierre asks.
It's hard to say. We can see just the surface of the sun, but depends on the size of the stars. It can be, with the smaller stars, it's for sure thicker. For the bigger stars, it must be thinner, and for the bigger stars and heavier stars, it must be thicker. I can't say. It's just understanding how it works. There is no possibility to measure that now.
And I'll try and answer that question for you too, Pierre. It's zero. There's zero lava there. Next question.
Okay.
Yeah, Pierre notes that we can sustain for fusion for quite a while now, which is what I was saying. The problem with fusion is that we can't sustain it forever because it costs so much. It hasn't. We haven't made more than we've put in. Pierre says also lava at 6,000 Kelvin would do more than just boil a little. It would evaporate immediately. Did you want to respond to that?
Lava is boiling. It's not evaporating immediately. Just boiling. Like any liquid.
But
boil the water.
But
that doesn't evaporate.
No. But the temperature there is a critical temperature where it evaporates, where it becomes gas, where it starts to break down.
Yeah, it's stars are boiling. Stars are boiling. As water is boiling, doesn't evaporate immediately. Boiling. The process.
Okay, Joseph Hinchy says this guy has no idea what he's talking about.
Okay, I can understand his approach. But can you show to everybody, the photo to Jupiter, that we can, see how gases looks like when we see gases. The atmosphere of the Jupiter is gases.
Yeah, but Jupiter has a entirely different chemistry, entirely different. We've got talking about Jupiter. Well, we're talking about the sun being hollow is like talking about a bicycle. It's a completely different thing.
When we look, Dylan, I'm getting muted somehow. I don't know why.
Sorry.
But when we look in an atmosphere of the Jupiter, and when we have real gas there, even if it is cold, everything is blurry. When we look at the sun, at the surface of the sun, everything is so sharp, sticking. You can see the small things, sharps, sunspots, and everything else. It's too sharp. It's too distinctive. When you look at that photo, it can't be gas.
That's because it's
gas.
It's plasma.
It has to be blurry.
It's plasma.
Even plasma, even bursts. Because gases are mixed.
It's plasma. It's plasma that is being affected by a very dense gravitational pull and the undulating temperature differences, which is why we see the black and the white ridges in there, and the magnetic loops that cause it to twist and turn.
Okay. Let me ask the question, you and the audience. So we now know what our solar system is. So we have a hydrogen star inside in the center, which creates helium through nuclear fusion. Then we have 4 rocky planets. So we are sure that they are rocky. Then we have asteroid belt between Mars and Jupiter. Then we have 2 clouds, of the asteroids around, in the same orbit of Jupiter. Then we go further. We do believe that we have 4 gas giants. The first one and biggest one is Jupiter, but it's just our wrong assumption. And then we have Kuiper belt, beyond the orbit of Pluto, which is all full of the rocks. And then we have Oort cloud, which is again rock. So where is the logic? Inside the, in the center of all that system of the solar system is the hydrogen, which unfortunately can't create anything heavier than helium. And how come that all that elements which came from supernova explosion created rocks in such a number and measure? So where is the logic in that? That's my question for you and your audience.
The rocks are created by what's called like a stellar disk. So when the matter is all in a cloud, and you have a dense clump in the middle that collapses in on itself and ignites into plasma because of the sheer density of the weight and the heat, then you get the gravitational object in the middle, which causes everything to start circling around it. When everything's circling around that big proto-disk of material, that's when they start to clump together into planets, and around those planets are moons, and the density of those, because they're smaller objects, and this is the key, because they're smaller, they're not going to ignite and become plasma like the sun does. They just remain as rock. And that's the difference between the planets and the stars.
How they have become a rock? Okay, how they can become a rock?
Because of their gravitational density.
How they can become a rock?
Through pressure.
I don't hear you.
Pressure.
I have pressure. From what?
The gravity.
What created pressure?
Look.
Gravity. How gravity can create the meteor?
Gravity creates pressure. It pushes things down. That's why in the middle of the Earth we have molten iron, because the heaviest, densest element goes to the bottom. And when the proto material comes in and collapses in on itself, because they form into balls that aren't of sufficient size to become stars, the inner area becomes molten iron and the outer area becomes rock.
Okay, so professor of astrophysics will give you 10. You will learn everything they wanted you to learn. But think of the logic. Think of the logic. How is it possible that when we have hydrogen inside, in the center of our solar system, how is it possible that the rocks are everywhere around?
Because rocks are the smaller trace elements. The vast majority of the universe is hydrogen and helium. That's why there are so many stars, and the smaller things, the things left over, the trace elements, they're the rocks. They're the ones that weren't big enough to become stars. Now, tell me, Goran, I'm showing you a photo of where stars are born. This is the kind of material that collapses in on itself and becomes the proto-systems that create solar systems and planets. But the big clumps burst into stars because they're plasma. What do you think is going on here that turns them into lava? Straight from gas to lava.
No, everything started from lava. But okay, let me tell you something what you don't know. If stars are created from hydrogen, if hydrogen created stars, our mathematical model which we applied, to that process, shows that just hydrogen and weight and mass of hydrogen is not enough to create even the first star. So even for that creation of the first star in the first place, heavier elements are needed, and they unfortunately don't exist at that time. Do you know that fact?
The Big Bang. The Big Bang created heaps of stuff.
Okay, so do you know that in that period of 1998 to 2000, we have finally discovered that our universe is spreading faster and faster?
Hang on, I want to go back to this point that you mentioned. Iron is the heaviest thing that a star can create. So before you get iron, before you get rock, you have to have plasma. Because plasma creates the iron, it creates the rock. So how is this shit here turning into lava straight away?
I don't have answer to that how lava came to existence. I gave some theory about it in my book, but that's just my best possible guess. I don't know how lava came to existence. I don't have all the questions. But
that's okay. Look, Goran, we're gonna have to tie this up.
Let me point again this. Do you know that our universe is spreading faster and faster?
It's expanding faster and faster. The expansion is getting faster. Yeah.
Do you know about it?
Mm-hmm.
Know about it?
Yeah.
Okay. So when that was finally discovered, those sincere physicists, astrophysicists, said this is something unprecedented. We don't understand something fundamental in physics in the nature. Because if there was Big Bang, the expansion of the universe must be getting slower and slower. And all experiments which led to this conclusion about faster and faster, expansion of the universe, basically were meant to measure what is the degree of slowing down of expansion of the universe. And they get the opposite, something unexpected, that we are getting, that our universe is expanding faster and faster. And then came to existence dark energy, like explanation. So, do you know how came to dark matter?
I think the jury's still out, isn't it?
Who?
I think that is still a question of science which has yet to be answered.
Okay, but do you know how that term came to existence? Who created that sentence or word dark matter?
No, tell me.
Okay, 1930, approximately 1930, Swiss astronomer and astrophysicist Fritz Zwicky was first able to observe the rotation of the galaxy. So what was puzzle for him? That galaxy was rotating like a wheel with the same angular speed, which requests much more matter and much more gravity, to keep it, hold like this and rotate like a wheel. So his conclusion was that there must be in the galaxy some matter which we can't detect at that time and see, and he gave the name for that dark matter. So, in inability to understand why galaxies rotate, like a wheel with the same angular speed, came to existence dark matter. We put in our equations 1x. Then, 70 years later, when we discovered that our universe is expanding faster and faster, again we were puzzled how it happened. It happens, and we brought y to the our theories, naming it dark energy. So we are getting to the more and more magic things of dark energies, dark matters. Then we are talking.
Goran, we need to wrap this up. Please bring your point home.
So so we are getting away and from the simplicity, from the logic and real physics, and we are bringing more magical things. Now people are ready to create, totally new standard model of the universe with the all particles which are all in the area of the dark. So we have dark stars, we have dark planets, we have dark light. Absolute nonsense, and we are getting totally crazy about it.
Well, look,
at the same time, we see just a 4% of the universe.
Garan, I'd like to thank you for coming on my channel today and for discussing this with me. You've been a great sport. I know I've been going hard on you, and I don't apologise for that, because I will defend the science when I can. So thank you, and I will leave you with one thought, because I think I knew where you were going with that. But just because one crazy theory turned out to be true once doesn't mean your crazy theory is true.
Okay, this is the thing to be discussed.
Okay,
so
thank you very much, Goran.
And I'm open if you want to do something in a follow. Yeah.
Okay.
Let me know.
Thanks very much.
You're welcome.
Good night, everybody.